Our project, entitled Storm in a Teacup, was an audio, visual and tactile installation. The system we designed records ambient noise from the area surrounding the installation, and it uses the amplitude levels of this sound to induce very low frequency sine wave vibrations in a mug of tea using a loudspeaker cone which is built into the surface of a table. What they hear might include others talking, general background noise, or themselves or their friends talking. This sound will be then made visual in the surface of the tea, but it will also be made tactile if they should reach out and touch the surface of the table which is vibrating. The purpose of our installation was to try to get people to reflect on how the noise they make and the noise that others make can affect our environment and those living in it, and to show that this may not always happen in a way which we might expect. And to take you through the patch, we'll just follow the signal flow from our input to our various outputs. So obviously the signal is coming in through the microphone. It's compressed using these parameters, which are sent to plus compound tilde, which is an external available online from SoundHack. It was a bit easier to use than the native compressor, so we used that. Then the compressed signal is sent to our limiter, which just for safety reasons is set to -1, so we don't get any very loud sounds which could blow the ear off any users. And then if we go into edit mode, we can see where this signal is going. So obviously the limited signal is going to a record tilde object to be recorded into our buffer, but we're also taking values for the amplitude, which are being scaled appropriately and sent into this split object for testing. So the signal is also sent in the meantime to analyzer tilde, which is another free external we got online. And this can measure noisiness, which is what we're gauging here. And that gives a value between 0 and 1. So if I be quiet for a second, you can see the general background noise is kind of between 0.7 and 0.9. But as I speak, this drops to kind of 0.5 or 0.6. And then if we introduce more tonal elements such as bells or phones ringing or people whistling or singing, this can drop as low as 0.2 or 0.3. So this acts as threshold for this split object. Values below this in amplitude will not trigger this switch, so they will not make it into the buffer, but values above whatever the threshold happens to be at the time will initiate the switch and will make it into the buffer. So we do this because noisy elements will have to be much louder to actually be recorded, but things such as voice or tonal elements can afford to be much quieter yet still be recorded, and they'll be recorded for longer. So we'll have much more interesting sounds, if you like, in the buffer than just background noise. So the switch which the split operates is initiating this toggle, and the toggle does two things. First of all, it enables and disables record tilde, so it obviously records into the buffer, but it also enables and disables this metro, which bangs a counter which counts up to 60,000, and this corresponds to the length of our buffer, so that when the counter gets to 60,000, it will mean we're at the end of our buffer, and it'll trigger this bang, which will turn off append mode just for 2 seconds, as you can see using this delay, and that resets the record head in the buffer to 0, so that it can constantly refresh all day. That's the record function. So then if we go into the play function, it just uses a simple play tilde on a loop. The signal is sent directly out the headphones, so that's essentially the buffer is exactly what the users hear in their ear, but it's also sent up to another analyzer tilde object, and this time we're gauging pitch. Now obviously a background noise signal isn't going to have any real pitch value, as in it is just noise, but the object does seem to find some sort of average or some sort of center frequency, and it moves around that nicely. So we send it up and it's scaled appropriately to, as you can see, between 10 and 36. Now this number between 10 and 36 is sent to this cycle tilde object as the frequency that this sine tone is going to oscillate at. Now this is the sine tone that is in our loudspeaker in the table. So this essentially sets the frequency of the wave in the mug. So up at 36, you'll see a very dense waveform with a very short wavelength, and down at 10 or 12, you'll see a much wider wavelength in the mug. So also coming from play tilde is a value for amplitude. This is scaled appropriately and averaged. The last 10 values are averaged. This is done so that you get a nice gradual rise and fall in the amplitude of the wave in the mug. Because this is sent into this gain tilde with a baseline of 100, just so there's always something happening, and it's sent into the gain tilde and essentially controls the amplitude of the sine tone that controls the mug. So